Yes, friends. We are discussing here alternating current. In last videos, I defined alternating current and measurement of alternating current. I told you that we can use only heating effect of current to measure alternating current, and which value is measured by any ammeter or voltmeter. We measure alternating current as well as alternating voltage. So which value of the current and voltage is measured? Because alternating current mathematically written as I equal to I0 sin omega t. I is the instrument, I0 peak value I have discussed. So in fact, I told you we use heating effect of current to measure AC. And we measure root mean square value of alternating current. Now what is the definition of root mean square value, which we write as IRMS, or अगर voltage हो तो VRMS. These values are written other way also. I will tell you later on. So how to define what is root mean square value? So the root mean square value of alternating current, AC current, is numerically or mathematically, you can say numerically, is defined as the square root of the average of square values of all possible current, value of all possible current in one complete cycle of AC. One complete means T by 2, T and T by 4, so the current vary like this. तो जितनी भी ये वैल्यू होगी सबका स्क्वायर का एवरेज इज रूट मीन स्क्वायर वैल्यू. मैथमेटिकली IRMS is equal to square root of I1 square plus I2 square plus I3 square plus so on up to 3 values, suppose n values, divide by n. I written here that root mean square value of alternating current AC is numerically defined as the square root of average of square value of all possible current in one complete cycle of AC. Mathematically this is a simple mathematics, tell this thing. But now practically, what is the meaning of this? Practically what is root mean square value of current and voltage? Practically, root mean square value of AC is equal to that direct current which produces same heat same heat as AC does when passed through the same conductor for same time. By practically we measure in terms of direct current. That direct current which produces same heat as AC does when passed for same time through same conductor, then that value of DC is called RMS value. For example, I am telling here, suppose on passing an alternating current through a conductor for some time, say 20 seconds or 50 seconds, 100 joule heat is produced. If that 100 heat joule is passed by, say, 5 ampere current, then that AC which passed through that will have 5 ampere as its RMS value. So I clearly written here. Actually, I was reading just a book here. Every book is involving physics in mathematics only. Practical meaning, they don't explain what they use practically. But when we pass electric current through any conductor, whether AC or DC, it produces heat. And by measuring that heat produced, we can measure the alternating current. So RMS, because this current keep on changing periodically with time, तो which value is measure? ये तो कोई भी फिक्स है ना, तो we measure root mean square value, है ना, and that is numerically equal to that direct current which can produce same heat as AC does. It is easy for us to measure DC. So when we measure AC, we measure in terms of DC, and you will learn in higher classes that the AC is measured by converting that to DC. In our home, the regulator is fixed 5 kilowatt, because of to avoid the fluctuation in everywhere it is there. In my room, the AC regulator is there. That voltage it is there. It is RMS value voltage, and that is made in terms of DC. So now, what is the relation between peak value and RMS value? Relation between IRMS and I0, the peak value of current. So I start like this, है ना? Here little mathematics of higher class is required, means which mathematics learned in class 12. 9th, 10th is not required here. So let an alternating current I equal to I0 sine omega t is passing through a conductor of resistance R. So when current is passed, heat is produced. So to calculate heat produced by this AC in one complete cycle, we proceed as follows. क्या भाई, h equal to integration 0 to t I square r dt. Heat produced I h equal to I square r t होता है. मैंने यहाँ dt को लिया. I have taken dt because current is changing for this time interval. dt we can take current constant. Putting the value of I here, or it is equal to integral 0 to t I0 square r sin square omega t dt. Now I think you might have learned this. In the bio student, please learn this much. We have to do this thing. H equal to I0 square r outside 0 to t sin square omega dt. In integration you will learn we have the integration for sin theta cos theta, not square theta. There is formula of cos 2 theta equal to 1 minus sin square 1 minus 2 sin square theta. From this we can convert this into I0 square r 1 minus cos 2 omega t. इसको इधर लाए, ये इधर चलाएगा, डिवाइड बाई 2 dt. This 2 is common here. You can write h equal to I0 square r by 2. भाई यार ठीक हो जा. चलो dt 0 to t minus integral 0 t cos 2 omega t dt. There is formula integration sin ax dx is equal to minus 1 upon a cos ax, and integration cos ax dx is equal to 1 upon a sin ax. So this will be how much? I0 square r upon 2. It is t, limit 0 to t, integration dx. Bio student, please learn this thing. Or minus 1 upon 2 omega and sin 2 omega t 0 to t. I0 square r by 2. The upper limit minus lower limit इतो t होगा. Now 1 upon 2 omega. Actually omega is equal to 2 pi upon t. So here it will become sin 4 pi t into t, because I have to put limit 0 to t. So when we put these values here, what do we get? This h equal to I0 square r by 2, and this is t minus 1 upon 2 omega, or it is sin t, sin 4 pi minus sin 0, and both are 0. ये भी 0 है 0. So this heat produced in time t is obtained as I0 square r by 2 into t. This heat H is the heat produced by alternating current in time t one cycle. t one cycle. अभी करंट क्या था हमारा? I equal to I0 sin omega t. This current was passed through conductor which is half for time t. Now if IRMS is that value of DC which produces same heat, if IRMS be the value of DC which produces heat H when passed through conductor of resistance R. In time t, then H will be IRMS square RT. Comparing these two equations, what do we get? IRMS square RT is equal to I0 square RT upon 2. And simply you get here, क्या भाई? IRMS square is equal to I0 square by 2, or IRMS is equal to I0 by root 2. This is a relation. Our AC ammeter or voltmeter measure RMS value, not peak value. So if you are asked to find current in circuit, it means you are asked to find RMS value. When in any problem you are asked to find the current drawn by the conductor or anything other, it means you need IRMS. Similarly, we can prove for. Similarly, VRMS is equal to also V0 by root 2. RMS value. Wherever something varying, this is called sinusoidally. Sine curve, if anything is changing sinusoidally, periodically with time, then if I0 is the peak value or anything, like if you write E equal to electric will be vary करते हैं ऐसे. तो E0 the peak value, RMS value will be E0 by root 2. 1 by root 2, in fact, root 2 upon 2, it comes out 1.414 upon 2, 0.70, 707. ये 1 by root 2 value है. तो IRMS you can also write as 0.707 E0 also, or I0. And VRMS the same way, 0.707 V0. So RMS value, these RMS values are also called as, इनके और भी नाम हैं. They are called also as effective values, as I effective or I virtual. Some people write virtual or I apparent. These different names are used while we are discussing alternating current or voltage. I hope you have got my point. In measurement of AC current or AC voltage, we measure RMS value, and the effect used to measure is heating effect. AC ammeter voltmeter consists of here a spring and connected to a pointer here. Since heat produced proportional to I square है, so here divisions are not equally spaced, because 1 square 1, 2, 4, 3 square 9 and so on. So AC ammeter, this is called hot filament ammeter. Hot filament ammeter. And similarly voltmeter, they measure. So these squares, these divisions in DC ammeter, all divisions are equally spaced. In AC ammeter, these are the distance keep on increasing as I increases. In next video, I will be telling some problems related with this. Thank you.